Hi, and welcome to this video. In this video, we're going to be tackling the problem on the screen, where you basically need to validate a binary search tree. What this means is that if this is the node, that means the nodes to the left need to be less than. So this applies here because 1 is less than 5. The ones to the right need to be greater than. So this does not follow the rule because 5 needs to be less than 4, which is not true, obviously. If we take a look at this node, then we can see that this is supposed to be less than, 3 is less than 4, perfect, and this is supposed to be greater than, which means that 4 is less than 6 or 6 is greater than 4, which works. So because it doesn't work at this point, we would return false because not the entire tree abides to this rule. However, in this tree, we would return true because 1 is less than 2, which is less than 3. So in order to solve this problem, we are going to be at this node saying that there is a min value, and we're just going to set this to the absolute min. And then we're going to have a max value, and we're going to set this to the absolute max. When we go to the left, we're going to change the maximum value to the one at the node here. So min is going to still be set to the absolute min, but max is going to be set to 5. It basically means that this node cannot be greater than 5 because that doesn't fit the rule. So in this scenario, we know that this is true. When we go down to this side, we're going to set the minimum is equal to 5, but the maximum we're going to keep at the current one it is, which is just the absolute max. This doesn't oblige to the rule, so we're just going to return false in this scenario, but I just wanted to continue explaining it. So let's just keep going down. We're going left here, so this time we're going to change the max value. So in order for this to work, I'm just going to assume that this value was 3 instead. So the min here is 3. This is just so that we can address what happens when you don't just have one layer of nodes when you go to the second layer. So here, it's going to be that the min stays the same, but the maximum is going to be reset. When we go to the right side, it's going to be the min is reset, so that's going to be equal to 4, and then the max is going to stay the same. So you can see that this part fits the tree, but at this position, the value here is equal to the min value. And when this happens in this scenario, or in this problem specifically, we're going to say that's not true. So that's how we're going to be walking through this problem. We're just going to set a max and min. And then when we iterate through each node, we can check whether or not that specific node matches the max and min conditions that it's supposed to. So I'm going to go over here and I'm just going to have this helper function here. And this is just going to be the recursive function where we can keep track of the max and min. So in our main function, all we need to do is return helper. Or if you want to change this, for example, to recursive, if that's a bit easier to understand what it does. So that's what I'm going to do, recursive. You need to pass in the root. And you can see here that we start with the absolute min and the absolute max. So in Java, that is integer dot min value. Oh, sorry. The first parameter is max, so we're going to do max value and integer dot min value. We're first going to say that if root is equal to null, we're just going to return true because obviously we're not dealing with a node that doesn't exist. The next thing we need to say is that if root.val is less than the minimum value, which means that um, if it was supposed to be 3, but this was, let's say, 2, that means it's outside the bounds. So this would mean we'd have to return false. There's also another scenario that if root.val is greater than max. That's basically saying if this was kind of back into 5. So in this scenario, our current node doesn't match the min rule. But if this node was, let's say, no, actually that's not the best node to do this at because we have an absolute max. If we are over here in this node, let's say 6, that means this is greater than the max value and therefore we need to return false. Because you can see here that it is greater than this node right over here. So that's why we said root.val is greater than max. And then we need to call root.left and root.right. So we're just going to say return recursive of root.left. And we're going, for root.left, remember that we update the maximum value. So we're going to say root.val, and we're going to keep the minimum value. And because we want the binary tree to be valid on both sides, recursive of root.left, the maximum stays the same, but we change the minimum value. So if we run this code, you can see here that we were able to get the right value, and if we submit it, you can see here that we get an error. And the reason is because we just said less than, but it needs to be less than or equal to if we return false. Because if you look over here, you can see that it was false when, if I erase this, it was false when our node is equal to the min or the max value. You'll notice that we get false again, and this is because this number is too big for integer.max and integer.min. So instead of having ints, we're going to change these to longs, and we're just going to change this to long, because long has a bigger threshold, which basically means that it can handle more numbers than just int can. And now you can see that we were able to submit this problem. So I hope this video was helpful and see you in the next video.